this is 75%. 75% mapped on 100%. This is your coursework, and the 25% will be from your lab. Okay. Okay. Before moving further, the overview of the signal processing, and we will be discussing something related to signals and systems as well. Well, you know that when we are talking about signal processing, in fact, we are talking about signals, and signals can be continuous time, signals can be discrete time, and signal can be digital, and consequently the processing associated with that will be continuous time signal processing, discrete time signal processing, and digital signal processing. What is a continuous time signal? Adnan, today is free. I mean, I'm not marking. Go ahead. Continuous time signals. The signals and systems में क्या grade था? बीटा. हाँ जी. है? No sir क्या? Anas, continuous time signal. There is no answer like an engineer. Anyone sitting in this class who can describe continuous time signal? Time and amplitude both are continuous. It is defined for all the values of time. I mean, this is the academic definition for continuous time signals. Suppose I'm speaking right now, and the waveform generated, if you record that and look at that on the oscilloscope, that would be the continuous time signal. That would be defined for all the values of time. So that's your continuous time signal, or we call that analog signal. Discrete time signals कौन से होते हैं? Great. And what is एक और चीज स्पेसिफिक है इस चीज के साथ? They are discretized in time but continuous in amplitude. What do I mean? Suppose करते हैं कि वैसे it's very difficult, but let's try. Now that's in fact, and that's your amplitude. So this is continuous time signal. Okay. और discrete time signal क्या होगा? Discrete time signal ये होगा कि अगर मैं I'm very sorry क्योंकि ये जरा मुझे थोड़ा सा इस पे टाइम लगेगा to be familiar with that. So it's 1, 2, 3, 4, and in that case that would become n. और ये क्या हो जाएगा? That is defined for discrete instance of time, but you can understand from here that amplitude is anything. Like अगर इस चीज का amplitude था 2.1 और इसका amplitude था 3.7, तो इन samples के amplitude जो हैं वो 2.1 और 3.7 ही रहेंगे. So there is no discretization in amplitude. So time axis पे we are getting discretization, but in amplitude there is no discretization. And what's the difference between discrete time signal and digital signal? That is discretized in time axis and discretized in amplitude axis as well. So what does it mean? That आपके पास ये जो 2.1 था, maybe आपके पास जो quantizer है उसकी resolution आपने 2 या 3 की रखी हुई है, तो in that case ये 2 हो जाएगा, ये जो 3.7 है ये 4 हो जाएगा. ठीक है? So that the values will be shifted according to the quantizer जो है आपके पास. अब ये क्या चीज है? Okay. ठीक है, clear हो गई बात कि what's the difference between discrete time, continuous time, and digital signal processing and signals. And then we can also skin the cat of signal processing between theoretical versus applied. Look, people have been working on the theoretical aspects of signal processing. Initially started in the 19th century, in 1860, when Fourier and Laplace given certain transforms. And the beauty is that still in 2020 we will be teaching and we will be studying Laplace transform, and you have studied in fact Laplace transform and Fourier transform and Z transform, all these things. So all these things, you can see that these are the outcomes of the theoretical aspects of signal processing, and continues to thrive even in today's world. The latest breakthrough in theoretical signal processing is wavelets in 1990s. And when we talk about applied signal processing, in fact, it is that you have some certain algorithm. Suppose I have taken an algorithm, and suppose it's independent component analysis, and independent component analysis is an algorithm which separates the source. Suppose I'm singing a song and there are two म्यूजिक इंस्ट्रूमेंट्स बिहाइंड, गिटार है और उसके साथ कोई और चीज आप डाल लीजिए, पियानो डाल लीजिए, एंड इंडिपेंडेंट कंपोनेंट analysis is an algorithm which can separate all these. My voice will be separated, the piano will be separated, and the guitar will be separated. So that's the algorithm which this can do. I mean, the source separation के लिए इस्तेमाल होता है. Now, the applied thing is that how I will be implementing it, whether I want to implement it using a computer, whether I want to implement it using a DSP chip, whether I want to implement it through an ASIC. ठीक है, तो ये उसकी applied चीजें हैं implementation के context में. Application के context में अगर बात करें तो sky is the limit. You start with telecommunication, our mobile devices. You start with what? सबसे पहले मैं अगर फोन पे बात कर रहा हूँ तो what will happen? It will be receiving that signal, source compression होगी, speech compression होगी, there will be different codecs applied on that. अगर आप उसमें हैं CDMA में हैं तो different codecs हैं, GSM में हैं, या आजकल के उसमें न्यू जनरेशन, फोर्थ जनरेशन, फिफ्थ जनरेशन 5G में हैं तो different codecs जो हैं वो available हैं. Those will be compressing those speech signals which the mobile phone is taking. उसके बाद क्या होगा? उसके बाद error correction coding होगी. Error correction coding के बाद क्या होगा? Modulation होगी to make that signal compatible with the air, because the signal has to travel in the air. ठीक है, bits जो हैं, these are the bits. ठीक है, लेकिन आपको सिग्नल को कंपैटिबल बनाने के लिए आपको उसको वेव फॉर्म में कन्वर्ट करना है, उसको सिग्नल में कन्वर्ट करना है. कंटिन्यूस टाइम सिग्नल बनेगा तो ही वो वहां जाएगा. डिजिटल सिग्नल आपकी डिवाइसेस पे है, डिजिटल यहाँ पे है, वहां पे डिजिटल नहीं. ठीक, तो कंटिन्यूस टाइम सिग्नल बनेगा, मॉड्यूलेट होगा. मॉड्यूलेशन होने के बाद क्या होगा? नाउ द चैनल विल डू सर्टेन इम्पेयरमेंट्स इन दैट सिग्नल. तो आप जब रिसीव करेंगे तो आप अडेप्टिव इक्वलाइजेशन करेंगे. अडेप्टिव इक्वलाइजेशन के बाद यू विल बी doing what? You will be error correction karenge aap, because you had added certain redundancies in your signal and your bits, and at the receiving end you will be removing those redundancies and you are getting your original signal back. So it's all signal processing. At every step of this conversation you are using signal processing. So audio signal के context में अगर बात करें तो music synthesis, you are generating a digital ऑडियो. डिजिटल में आप गिटार की वॉइस प्रोड्यूस कर सकते हैं, पियानो की आवाज प्रोड्यूस कर सकते हैं. इसी तरह से कंप्रेशन, रिकॉर्डिंग, सो ऑल दीज थिंग्स दे आर एसोसिएटेड विद ऑडियो एंड स्पीच सिंथेसिस, स्पीच कंप्रेशन, स्पीच एनालिसिस. सो ऑल दीज थिंग्स इंक्लूड सिग्नल प्रोसेसिंग. Analog to digital conversion, whenever you will be using digital or discrete time signal processing, you need analog to digital converters, because you have signals and you have to process it through digital devices. So the first thing which will come into your in your way, that would be A to D converters. So that's one of the applications of this area. Then you have video compression, all these MPEG, JPEG kind of things. DCTs, discrete cosine transform, these are all outcomes of this area: images, image enhancement, image reconstruction, चाहे आप हिस्टोग्राम कंपनसेशन करना चाह रहे हो, चाहे जो कुछ भी हो, उसमें आपको ये सारी चीजें जो है करनी पड़ेगी. रेडार, दैट्स one area of the signal processing. You're sending some signal and then you are waiting to receive that signal. So that's signal processing. Sonar, what is sonar? सबमरीन यूज कर रही हैं. इट्स काइंड ऑफ रेडार. एक्टिव भी हो सकता है सोनार और पैसिव भी हो सकता है. पैसिव सोनार ये है कि एक्टिव सोनार इज ज्यादा सिमिलर है एज विद रेडार बिकॉज you are transmitting a pulse and then you are receiving it in that case. But in passive sonar, you're just passively sitting and listening what is happening. Biomedical, MRIs, PETs, ठीक है, ultrasound, all signal processing. और MRI में क्या है application? FFT, fast Fourier transform या Fourier transform की application है. ठीक. जियोफिजिकल में आप माइनिंग के लिए, आप ऑयल एक्सप्लोरेशन, माइन एक्सप्लोरेशन के लिए यूज कर रहे हैं. एंड एप्लीकेशन कौन सी यूज कर रहे हैं? डीकन्वोल्यूशन. सिंपल, आपकी इंस्ट्रूमेंटेशन जितनी भी है दैट इज यूजिंग डीकन्वोल्यूशन, ब्लाइंड डीकन्वोल्यूशन और सेमी ब्लाइंड और नॉन ब्लाइंड डीकन्वोल्यूशन आप यूज करते हैं. सो दैट वाज some overview of the signal processing, strongly connected to what you have done and in fact what you haven't done in signals and systems. I would suggest कि जो topics आते जाएं आप उनको repeat करें in your signals and systems book, because of course I have to cover the content of the DSP. I will not touch signals and systems. Yes, the contents coming here and the question asked from you, I will touch that. Otherwise I will be hoping that you know everything. So I would suggest कि आप इसको वहाँ पे भी देख लेंगे. So let's start, which is the basic type of signal, and you are quite aware of that. The initial function, which is unit step function, but before unit step I will go to unit impulse function. What is unit impulse function? सिग्नल्स एंड सिस्टम्स पढ़ चुके हो बेटा? जी बेटा आप बता. यूनिट इंपल्स, ऊंचा 0 पे 1, 1 पे 0, जो भी है बोल दो, बाकी तमाम पे 0 होता है. This is called in discrete time signal processing or discrete time signals. This is called Kronecker delta. Kronecker delta. Oh. This is called Kronecker delta. The counterpart in analog is what? Analog domain में क्या है? That is called direct delta or Dirac delta. Now this is totally impractical, theoretical thing. This is very practical. Why I am saying that this is theoretical? Because by definition, any idea what's the definition of that? शेप तो आपको शायद अंदाजा हो कि क्या थी शेप, याद है? पर इसका मैं क्या करूं भाई, मेरी अभी तक ओरिएंटेशन जो है ना वो बन नहीं रही है. इसको रखते हैं शायद. अच्छा, much better. So this is my direct delta. ये arrow जो है, this is indicating that this is a delta, that this is a unit impulse in analog domain. And theoretically, what is it? It is something like that. The height of this is, the width is delta, the height is 1 over delta, and as delta tends to 0, the height becomes infinity, and that height is shown here, this one, that it is approaching to infinity. So area under the curve is 1. Okay? So this is your direct delta, which is purely theoretical, and purely theoretical in a context when you have seen, in fact, sampling. The theoretical aspect of sampling has been supported by this theoretical thing. This was used there. Sampling process पढ़ा है ना? कैसे होती? Who was the teacher? अच्छा, ये वो ग्रुप है. Got it. ज्यादा शिकवा करने की जरूरत नहीं है. मुझे पता है आप कितने काबिल हैं. अगर वो पूरा भी हुआ था, दूसरे सिंडिकेट्स का पूरा हुआ, वो मुझे ना बताएं आप. But anyway, it's all right. I will consider this as well. Okay जी, clear हो गई बात. Now we are moving toward the unit impulse, which is Kronecker delta, and by definition this is delta of n. This is called delta of n. ठीक है? इसको हम यूनिट इम्पल्स को हम कहेंगे डेल्टा ऑफ एन, और उस वाले को हम क्या कह रहे थे? दिस वाज डेल्टा ऑफ टी. ठीक है? ओके. सो डेल्टा ऑफ एन इज इक्वल टू 1 फॉर n इज इक्वल टू 0 and 0 for all the other values of n when it is not equal to 0. And unit step function क्या है? You are familiar with this. Unit step function क्या कह रहा था? Which was u of t. U of t क्या था? U of t was something like that. यानी t से नीचे जो है, t is less than 0, so that's the continuous version of that. This is u of t. So when t is lesser than 0, it is 0. When t is greater than 0, it is 1. ठीक है, इसको लिख देना चाहिए, that is 1. Clear हो गई बात बच्चा? Okay. Similar here, just the discretized version of that. Now it is u of n, which is 0 for n lesser than 0 and 1 for n greater than equal to 0. So only the sampled version of the unit step function in continuous domain. Any questions till now? No questions? Okay. Team, यहाँ से वो नहीं हो सकी. रिकॉर्ड तो मैं लेक्चर कर रहा हूँ, अपलोड मैं कर दूंगा. So the people who are not sitting here right now, they please communicate कर दीजिएगा कि वो उससे जो जिस तरह से पहले पिछले सेमेस्टर्स में होता रहा है, ये लेक्चर जो है ये अपलोड हो जाएगा, आप इसको देख लीजिएगा. क्योंकि टीम यहाँ से कनेक्ट नहीं हो पा रहे थे. आई डोंट नो व्हाट्स द लॉजिस्टिक इशू, बट आपका फर्ज है कि दूसरे सीआर के साथ जो जेन्युइन सीआर है somebody else, यही है, तो दूसरे में कोई और होंगे, तो जो भी है कम्युनिकेट कर लीजिएगा उसको, सो दैट के कोई फिर मसले मसाइल ना हो. देन साइनसॉइडल सिग्नल. साइनसॉइडल वी नो दैट इट्स कोसाइन ले लें या साइन ले लें, दीज आर ऑल sinusoidal signals. Cosine omega t, omega is the frequency, and if we are interested in the discretized version of that, those will be just the samples of those continuous time cosine signals. So here it will be cosine omega naught n or cosine omega n. T is replaced with n, so it's a discretized version of cosine omega naught n. Okay, got it? And similarly exponential, अगर a raised to power t है तो आपके पास ये सिग्नल है. But there is one thing very important which is not written here. What's that? It's a decaying signal. So what will be the condition on a raised to power n? A less than 0. It's a raised to power n. Discretized है, a raised to power t वाला नहीं है मामला, n वाला मामला है. तो a raised to power n, a is some constant, and this constant, if this is lesser than 1, in that case it's a decaying, or if a is greater than 1, in that case that would be exponentially a rising signal. So a raised to power 0 is 1, a raised to power, suppose it was 0.9, so in that case 0.9 raised to power 1 is 0.9, 0.9 raised to power 2 is 0.81, so it is decaying signal. So that was it. Then there are certain basic operations, and what are those basic operations? It is shown here, y of n is equal to x of n minus nd. This is ideal delay. So we will talk about this later. इसको देख लेते हैं. So sum and difference. So if you are interested in summing up two signals, one is x1 of n and the second one is x2 of n. In that case, the y of n, which is the addition of x1 of n and x2 of n, what you will be doing, you will be align करेंगे आप signals को, sample by sample जो है आप add up करेंगे उन signals को, तो आपके पास जो है addition आ जाएगी. Similar case with subtraction, and अगर आप multiplication करना चाह रहे हैं तो in that case that would be sample by sample. Any questions till now? Delay को हम बाद में देख लेते हैं. Any questions? Some more difference. दो signals हैं जी. This is my x1 of n, okay, and if I am interested in knowing y of n, which is nothing but x1 of n plus x2 of n, then what it will be? Sample by sample addition you have to do. So 1 plus 2 is 3, 2 plus 4 is 6, and 3 plus 6 is 9. So that's your y of n. Similarly, if you are interested in knowing suppose z of n, which is equal to x2 of n minus x1 of n, in that case one, 2, and finally 3. ठीक हो गई बात. और अगर मल्टीप्लिकेशन करनी है तो इन दैट केस क्या हो जाएगा? सपोज u of n is equal to x1 of n into x2 of n. So in that case what it will be? जी जनाब. 2, 8 and 8. Clear? Have I answered your question? Great. Similarly, if I am interested in knowing x1 of n minus x2 of n, what will happen? The values will be swapped. So 1 minus 2 is minus 1. In that case, क्या हो जाएगा? Minus 1 is, got it? So let's write it here as well. That's u of n, and let's make it m of n. M of n is equal to x1 of n minus x2 of n, and in that case what it will be, जी क्या हो जाएगा? 1, 2 minus 4 is 2 minus side से, और 3 minus 6 is, so it's 2, it's 3, so direction is reversed. Got it? कोई confusion? चलें आगे, गुड, ओके जी। डिले को अब देख लेते हैं, फिर बाद में चलते हैं। ओके, व्हाट इज डिले? किसी भी सिग्नल को आप डिले कर सकते हैं या एडवांस सिग्नल मैनिपुलेशन के कॉन्टेक्स्ट में। सपोज इफ यू हैव सम सिग्नल, suppose if you have some signal, so this is my x of n, and I'm interested in knowing x of n minus 3. What does it mean? It means that I want to shift that signal 3 samples. ठीक है, किस तरफ शिफ्ट करना है, that's very important because it's always confusing for the students. Whenever you see these kind of things, always ये जो आर्गुमेंट रखा हुआ है, इस आर्गुमेंट को n-3 को उठाइए और इसको 0 के इक्वल करिए, एंड दैट वुड शो यू कि आपका जो पहला सैंपल है वो कहाँ जाएगा, n इज इक्वल टू 3 पे। ठीक है, सो सपोज इसका एक तरीका तो यही है कि आप स्ट्रेट अवे इसको उठाइए। सो दिस इज दैट वाज 0 1 2 0 1 2 3 4 एंड 5। सो 0 1 और 2 पे नहीं होगा, बल्कि अब कहाँ से, 3 से आपका स्टार्ट। So now your y of n is equal to x of n minus 3. This is your y of n. Agreed? There is another way of ये अगर आप ये काम नहीं करना चाहते तो I can do it like that कि मैं देखूंगा मेरा y of 0 क्या है। y of 0 is equal to what? y of 0 is equal to x of minus 3. y of 1 क्या है? x of minus 2. Sorry, y of 2 क्या है? x of minus 1, and then y of 3 क्या है? That is x of 0, and y of 4 क्या है? That is x of 1, and y of 5 क्या है? That is x of 2. So now you can see what is happening, that x of minus 3, there was nothing at minus 3. This was minus 1, minus 2, minus 3. So x of minus 3 was equal to 0. X of minus 2 is equal to 0. X of minus 1 is equal to 0. So this is equal to 1, this is equal to 2, and this is equal to 3. So that's the shifting. आप एडवांस भी कर सकते हैं. Suppose I am interested in knowing y of x of n plus 2, y of n या y1 of n कह देते हैं. So that is, if it is equal to x of n plus 2, in that case you will be equating this n plus 2 is equal to 0, and this would indicate that your signal will be shifted at minus 2, and the signal will be something like that कि आपके पास minus 2, minus 1, 0, 1, 2, this is my y1 of n, and आपके पास यहाँ पे आ जाएगा, सॉरी ये यहाँ पे मुझसे गलती हुई है, this is 1, 2 and 3, एम्पलीट्यूड चेंज नहीं हो रहा है, the 1, 2 and 3. Agreed? Questions? बोले माइनस एन प्लस 2 हो, यस दिस इज, जी जी। देखिए अगर आपके पास ये सिचुएशन है, देयर इज सम सिग्नल विच इज y2 of n and that is x of minus n plus 2. That's why I said कि आपने हमेशा यही काम करना है to avoid any kind of confusion. So minus n plus 2 is equal to क्या हो जाएगा? That would be equal to 0, and that would indicate n is equal to 2. So it's advanced. It's not delayed. Advanced हुआ है. Advanced. इसको एडवांस कहते हैं, ठीक है। जो माइनस साइड पे है, इस साइड पे है, जो इंडेक्सेस 1 2, यूं समझ लीजिए 0 इज द रियल टाइम में अगर हम बात करें तो 0 का सिग्नल जो है जो इस वक्त मिलेगा, इफ एट दिस मोमेंट आई एम स्टैंडिंग एट 0, नेक्स्ट सैंपल जो है वो 1 वाला है। इसका मतलब अगर मैंने इसको 0 वाले को 1 पे कर दिया तो आई हैव डिलेड माई सिग्नल, और अगर मैंने 1 पे कर दिया है तो वो सिग्नल तो आ चुका है. आई वॉज स्टैंडिंग एट टाइम t इज इक्वल टू 0 और 0 सेकेंड्स पे खड़ा हुआ था, वो तो गुजर चुका है. ठीक है, दैट इज एडवांस्ड. एंड ये थोड़ा सा कंफ्यूजन होती है, लेकिन इसको जरा ध्यान में रखिए जी. n इज इक्वल टू 2 पे एडवांस है, सिग्नल गुजर चुका है. n is equal to 0. That's what I was explaining. Okay, we are standing at reference time जो है that is here. I'm standing here at time t is equal to 0 or n is equal to 0. n is equal to 1 is what? Sorry, n is equal to, you are right. So -1 or -2 is advanced and n is equal to 1 and 2 is delay. You are right, absolutely right. वो इस तरफ है, मैं उसको -1 और 2 उधर गिन रहा था. You are absolutely right. ठीक हो गई बात. So 1 and 2 is on the right side. They are delayed because they have to come, and -1 and -2 are advanced because they are gone. Let's move further. Okay. Any signal, that's the most important concept. Any signal can be decomposed into shifted weighted impulses. आपको पता है impulse क्या है? You have seen impulse. Weighted impulse क्या है? Okay. ये जो आपको 2 नजर आ रहा है, आपने इस सिग्नल को देखा यार. चले मैं इस सिग्नल को आगे चलते हैं और let's see. What is this? It is delta of n. Why? Because I haven't written anything and now I write 1 here. So it is delta of n. Agreed? Okay. Now what is this? It is 2 times delta of n. It means I have scaled my impulse with 2. Okay? Okay. What is it? It is delta of n minus 1. My impulse has been delayed. N is equal to 1 पे पहुंचा दी. It is shifted, and then what is it? It is 5 delta of n minus 2. So it means it is weighted with 5 and shifted by 2. So weighted shifted impulses. These are the weighted shifted impulses. Clear ho gayi baat? Now we are saying that any signal, any discrete time signal can be represented or can be constructed or can be decomposed into weighted shifted impulses. Suppose we have this signal. Okay. Suppose कह देते हैं जी -2 पे, this is my x of n, इसको मैं कह देता हूँ, चले कोई वो देने की जरूरत नहीं है. So what is it? मैं इसको ब्रेक कर रहा हूँ, इस सिग्नल को ब्रेक किया मैंने और मेरे पास ये इम्पल्स आ गई. यानी पूरा का पूरा ये सिग्नल जो है इसको मैंने लिखा x of -2. x of -2 is what? That's the amplitude, that's the scaling factor, that's the amplitude of my signal associated with this. So this is amplitude, उसको हमने कहा है that is x of -2, just a notational thing. Overall signal is x of n और n is equal to -2 पे जो चीज रखी हुई है वो x of -2 है. That's the amplitude of my this impulse. So this is my x of -2 and of course that was an impulse but that was shifted delta of n plus 2 पे है. Agreed? n is equal to -2 पे ये रखी हुई है. अगली को देखते हैं. That is what? That is x of -1 delta of n plus 1. Similarly here x of n, x of 0 हो जाएगा delta of n because there is no scaling involved here. x of 0 जो भी वैल्यू थी, x of 0 delta of n because there is no shifting involved here. Similarly here अब shifting आ गई. x of 1 delta of n minus 1 and then x of 2 delta of n minus 2. सो ये क्या चीज है, इसका जो एम्पलीट्यूड है दैट इज एक्स ऑफ 2, इसका जो एम्पलीट्यूड है दैट इज एक्स ऑफ 1, इसका जो एम्पलीट्यूड है दैट इज एक्स ऑफ 0, और इसका जो एम्पलीट्यूड है दैट इज एक्स ऑफ -1, एंड दीज इम्पल्सेस आर शिफ्टेड। तो उसको इस तरह से रिप्रेजेंट कर दिया, एंड वी नो व्हेन वी आर एडिंग दीज सिग्नल्स वी आर डूइंग व्हाट, we are adding sample by sample. So when you will be adding all these 4 or 5 signals, you will be getting this thing. Agreed? And that's the mathematical way of writing the same thing, that x of n is equal to what? K is equal to, k is the dummy variable now, k is equal to -infinity to infinity x of k. What are these x of k's? These are the amplitude. K vary कर रहा है, K -infinity से +infinity तक चल रहा है. So in this part it is moving from -2 to +2. So K is equal to -2 to 2 x of K delta of n minus K. So if I am interested in writing this signal, so what it will be, x of n will be equal to, I'm just expanding the equation, and the pictorial representation will be shown here as well. So that would be x of -2 delta of n plus 2. -2 है ना, k माइनस है तो इधर इस इक्वेशन में डालेंगे तो k माइनस प्लस हो जाएगा, प्लस x of -1 delta of n plus 1 plus x of 0 delta of n minus delta of n, there will be no okay, plus x of 1 delta of n minus 1 plus x of 2 delta of n minus 2. Now you can, this is the same thing, this is the same thing. Any confusions, any questions, please ask. हाँ जी, भाई साहब, okay. X of -2 is, no, it's not the location. It's not the location. It's the amplitude. X of -2 is notational है, इस चीज को ध्यान में रखिए. X of -2 is the amplitude, as we were saying here. जैसे 5 था, जैसे 4 था, ठीक है ना? It is just like that. 5 or 2 or 1, that is the location, amplitude इसका. So just a notational way of doing it. ठीक है, कंफ्यूज होने की जरूरत नहीं है. So that is, क्योंकि लोग कंफ्यूज कर जाते हैं, this is x of n. X of n is the signal, general signal is x of n, and now -2 पे उसका जो एम्पलीट्यूड है that is x of -2, -1 पे जो उसका एम्पलीट्यूड है x of -1, but what is it? 5 what? 5 multiplied by what? 5 multiplied by the shape, the impulse at that location. Impulse अलग से देंगे. So impulse at that location, -2 पे एक impulse है which is multiplied with x of -2, which is the amplitude of that. So that's why we are saying it's the shifted weighted impulses. और उनको जब आप add up करते हैं तो you will be getting your construct कर रहे हैं, synthesize कर रहे हैं अपने signal को. Or the other way around, that if you have a signal, any discrete time signal, you can decompose it into shifted weighted impulses. आपके पास shifted weighted impulses हैं, you can construct a signal. You have a signal, you can decompose it into shifted weighted impulses. Questions, please. Thank you very much for asking this. This is a very important thing. Yeah. आप टाइम बताएंगे मुझे, कहाँ तक होता है? So should we stop here? Okay. Thank you very much, and thank you very much for the people who are not present here. Inshallah Taala, I hope next time क्योंकि इस दफ़ा माइक्रोसॉफ्ट टीम्स पे कुछ इशू हो गया था इस क्लासरूम नंबर 13 से. So I hope कि everything will be fine next time, and we have a class tomorrow morning at 8:45. So we will be starting convolution and all these kind of things which you have already studied. So inshallah ta'ala, the people who are not sitting here, I hope and I suggest that you will be looking at this lecture. I will be uploading it on the team. Thank you very much. Thank you.